Now, this is about the concept of the injection molding. Unlike the other MIM manufacturers, we have been focusing on achieving the net shape with only the molding step, without any post-machining. Most MIM manufacturers available in the different countries, different continents, were established as first as metal parts manufacturers using different technologies. Thus, if they cannot achieve the net shape, they do the post-processing in order to achieve that net shape. It means they do not hesitate to introduce a post-machining process, a secondary process. And in our case, we have established ourselves as a plastic injection manufacturer, as mentioned. So we are very keen to achieve the net shape molding where possible. Therefore, the requirement level towards the mold design or tooling is far much higher than other manufacturers. So when we are making such part, conventional MIM manufacturer would probably say, well, it seems to be easier to make the side holes with secondary process, which means by machining. We would say, let's make the entire component with the molding only. So only injection molding process, no secondary process involved. This is the key to our ability to manufacture finger-sized, complicated metal components for serial production. This allows us to more chances to reduce the lead time and the cost, and also the freedom of design opens up, since you do not need to do a secondary process by machining. The next slide is showing our technical structure in our MIM process. The fundamental layer is organized with 3 sections: the material, mold, and the injection molding condition. These 3 elements will decide the green part quality. As I said, green parts are the part after the injection molding, before the binding and sintering condition, the sintering process. And then the debinding and sintering condition will also contribute to the final MIM components quality. And today we are introducing our belief or way of thinking about the mold. Since we request a world-leading level in mold tooling, we intentionally do not manufacture or tool the mold in-house, but rely on our mold manufacturing partners' expertise. This is because we consider it is not easy to achieve an outstanding level of mold manufacturing if we do it in-house. So we have several mold manufacturing partners, and we choose a mold partner depending on the design of the component, since the USP of each mold partners are different. For example, if we are doing micro gears, we ask the mold manufacturer who is only doing the gear mold. So we differentiate from the component to component, depending on what we are making. Today, we invited Sayama Mould Manufacturing in this webinar. And Sayama is not only a mold manufacturer, but also plastic injection molded parts manufacturer. They're very good at microstructure manufacturing, such as microchannels for the semiconductor industry. Today, we have invited the COO of Sayama Mould Manufacturing, the partner that manufactures mold that realize our micro-MIM technology. This is Mr. Soichiro Oba, CEO of Sayama Mould Manufacturing. Thank you very much for joining us today.
Thank you, Ms. Nakamura. Hello, everyone. Thank you for joining us today. I am Soichiro Oba from Sayama Mould Manufacturing.
So, first, we fell in love with your precise mold manufacturing technology, and we would like to hear a little bit about your company, please.
Okay, let me introduce ourselves with a brief introduction. So Sayama Mould Manufacturing is the mold manufacturer, a small, medium-sized company in Japan. Saitama, it's called the Saitama Prefecture, which is the 1 hour distance from the central Tokyo. So we are specialized in micro-precision manufacturing. So we are taking care about our location of factory and then also how we build the factory itself. So the picture on the left side is our location. The white roof one is our factory. As you can see, it's surrounded with all the woods and gritty leaves. So the reason why we have a factory in here is because we are focusing on the micro-precision process. So we have to avoid from any vibration from the outside because it affects during our the nano control of the micro-precision process. So that's the location is one of the reasons. And the other reason why we have here and then we build a factory is the picture on the right-hand side. This is showing our factory inside. We always control the temperature and then humidity inside of the factory. So we always keep the temperature 24 degrees and plus minus 1 degree.
Please explain to the listeners about some of your product examples.
Sure. So this is some of our examples of the micro-precision products, what we have done. So the top on the left side is a micro gears, which has 0.5 millimeter diameter, and a module is 0.025. This gear is for the micro motors. And this one we made the mold, and then we do the production by ourselves. And the left side on the bottom is a optical connector. It's called the empty ferrule, the single mode. There is the lines of the connector holes, which has 0.125 diameter, 125 millimeter diameter. And the positional tolerance requires 0.5 micron on the plastic part. So this is the very tight tolerance requirements. Yes. And yes, we have the mainly to produce the gears or the connectors and then semiconductor products before. Recently, we applied those micro-precision technology and skills into the medical field. So the right-hand side, the top is a microfluidics, which is the biomedical field product. This one is for this one is using for the vaccine test for the COVID-19 also. So the demand is getting higher and higher now. So we have the 400 holes and 200 channels in one product with a complex texture on it. So this requires very high level of the micro-precision technology. And yeah, and right side on the bottom is 0.35 mm pitch connector for the smartphone. So this one is one of our biggest business for now. So probably each of you have our connectors inside your smartphone. So it is very high volume, but it requires very fine pitch control, and then also the tolerance, tighter tolerance on it.
Yes, this is what we saw last week in the article. When we opened the newspaper, one of the top industrial newspaper, on the front page, we saw Sayama, which was like, wow. So we will show you now.
Okay, yes. So this is a new one by our R&D section. So this is a plastic injection needle made with plastic material called PEEK, P-E-E-K. The injection needle in the world, in the market, is all made with the metal stainless steel. But we developed the plastic needle by ourselves. Its size is 32 gauge, which has 0.24 mm outer diameter on the tip of the needle. And also we have a hole through the needle, which has 0.07 mm diameter only. So it's very small.
Mm-hmm.
And then this is a plastic injection needle. So we can make by injection molding, which means we can have production stable comparing to the process one by one.
Mm-hmm.
And then also we have the design of the needle, which has the round shape on the tip of the needle.
If I remember correct, it said something like over 1 million parts will be produced with this.
Yes, in 2 years, we are going to have a mass production. Now it's at the very beginning of the R&D stage.
Mm-hmm.
So just it came up as a sample now, but we will develop the mass production system, and then we'll try to launch in the market in 2 years.
Okay, yeah, and if you can achieve this kind of size with plastic, we can probably achieve even smaller with MIM.
Absolutely, yes. We have an opportunity to apply this technology into the MIM also.
The next slide, which we would like to talk about your cutting edge equipment or facility. Could you please talk about it?
Sure. As we focusing on micro precision process, so we have all the machines to process the mold inserts, also specializing to the micro precision process. But our challenge is we always try to achieve the micro precision process all the time. So we always have a communication with the machine makers. On the slides on the right side. Yeah, so for example, we have Mitsubishi Electronics for the EDM machines, for NUC for the injection molding machine, and the Makino has the machining center for the micro precision field. So we always give our feedback after we are doing the R&D, the micro precision process, to those makers and their engineers in the machine makers, and then they apply our feedback into the new machines for the next generation. Mm-hmm. So we have the good relationship with the makers, and we have a win-win relationship. That's also the important to do one of the best micro precision.
Mm-hmm.
So,
yes, it is worthy to know that this feedback from a user who is at the highest level on the mold manufacturing is reflected in the next model, and then they can sell it to different markets all over the world. That's excellent.
Exactly. Yes. The machine maker is always willing to get the feedback from the users. So yes, we are not just like complaining to them. So we always, I know their machines are very good, but we want to have more. We are giving the tips to the next generation. So it really helps each other.
Yes. Yes, we understand because we also have developed a furnace with furnace manufacturer, and we understand that there is a lot of benefits by developing the equipment between the users and manufacturers. So it is a great way to get even better equipment. Now we would like to show you some components that we have developed together that we are allowed to show. And this is an integrated micro wheel. Several of these can be placed in 1 square millimeter size square on a grid sheet like this, which means they are very small, as you can see here. And it's a component that many people are very surprised to see that it's even possible with MIM technology. What was the challenging point of this components mold for you?
Well, this one is absolutely the challenging project for us also. Well, because this size is also one of the smallest size. Well, what we have done before. So this requires the small separated insets of the mold, which means it was very difficult to do the assemble into the one mold. But actually, the parting line is in the middle. It separates the inserts in it. So it requires very fine control of the dimension and then also the fitting each other. So it requires the very tight tolerance also, but we've applied our experience of the micro mold based on, for example, like micro connectors, as I show you. So it was challenging, but it came out the good product in the end. So
yes,
it was good.
Yeah, for us it was a mold that let us know that your technology is based on this history over 50 years, which led to the one and only mold technology. And
yes. Oh, and then not only the parting line, but also you can see the shaft on the vertical, right? But it's not a one through the pin. It's actually separated into the top and the bottom, the cavity and then core side. So the shaft alignment was very difficult also. And then it requires very fine the control technique and skill.
Yes, yeah. And I think the fact that you're also mass producing plastic components with microstructures and very tight tolerance, that makes it possible for us to be comfortable to consult with you about the mold design that is considering the productivity and also to challenge shapes that benefit from our micro-MIM technology. Next. So this is called micro nozzle, and I'm going to put this video on so you can see the whole view. And here on the tip, there is a tiny hole. I'm not sure if you can see, but this is the picture, and here's 30 micron, and the hole length is 300 microns, so it has the aspect ratio of 1:10. And we were moved when we saw this, the liquid coming out of the tip of the nozzle as we observed under the SEN. What was your thought into the mold that can mass produce holes with this kind of size?
Well, first of all, this is the very good example for advantage of the MIM as it's a shrinkage. Actually, the mold center pins to make the hole is a 50 micron diameter. But after it came out as a metal parts, it became the 30 micron after shrinkage. So it's showing we can make even smaller by MIM comparing to the general plastic injection molding, comparing to the shrinkage. Yeah, so this is the very interesting point. Mm-hmm. And then also, this one is made by the teams of the small size companies in Japan. Mm-hmm. For example, the center pin is made by our partner company in Japan, and then we put it together into the one mold as a mold maker. And then we pass it to the micro-mim Japan to make the metal mold after the MIM process. Mm-hmm. So we combined all the special technology and then skills together. So this is showing the good example of the alliance of the companies.
Yeah, and of course, the accuracy of the micro-pin made by another partner is really impressive, but we also understand that the surface smoothness of the mold is very important, right?
Yes, this one also required verifying the smooth finishing of the surface, because if the surface is rough, the product stick into the mold, so it will affect the quality after it came from the mold. So it required the very smooth surface finishing. So it requires not only the machine finish, but also we have to have the hand polishing to complete the smooth surface. So it was challenging, but we could show the capability of the craftsmanship of the mold.
Yes. So this is like mastered in Japan.
Exactly, yes. Right.
I would like to thank you for being our guest today, Mr. Oba. We really appreciate it.
Thank you very much.
Thank you very much.